Now,
All right, folks, welcome to the next edition of Firefighting Fridays here on Fire Engineering Radio. We got Jeff Shupe and Strategic Fire Training. Today we're going to be covering a couple of videos from the Elkhart Brass Brass Tacks and Hard Facts series that they shot a couple years back. And both Jeff Shupe and Jerry Knapp are going to cover a couple of the videos that they feel are important to go over. And then we'll round out the commentary with Chad Gruver and John Mateer and myself. So let's get started here. Jeff, can you set up this 2-inch line brass tacks video? Tell us about what it was like to put that video together with Elkhart, and what were some of the takeaways for them before we roll the tape here?
I think that I was fortunate enough to have a long time background with 2-inch hose. Going back to, if you take a look, the department was looking at 2-inch hose back in the late 70s. And it was all part of that program, Project Fires, that I've mentioned so many times in the past, that many fire departments were getting into different sizes of attack lines. And so 2-inch was one of those things that, you know, it always been there, but it never had any popularity. So we made a changeover in the Cleveland department to 2-inch hose, along with 1 3/4 and of course 2.5 on the engines. And the 2.5, or excuse me, the 2-inch hose being back then, that was I think 82 when that happened. You know, it was old rubber line hose, and the couplings were 1.5 inches, and the 2-inch hose was equipped with an automatic nozzle. And that was the feature about 2-inch hose, was that people thought it was going to be the hose line to replace 2.5. And as I said in one of my brass tacks videos, that that was a mistake, because the 2-inch hose never did attain the flows of a 2.5. And the 2.5-inch hose we regard it as being the king of hose lines, because there's so much you can do with it. It's so effective on a fire. We've heard things that people think they can take 2 3/4 and equal the flow of a 2.5, and they can't. It's just that simple, because when a 2.5 is flowing and you're getting the biggest bang you can from that 2.5, there's nothing like that 2.5-inch solid stream. And when you're doing 325 gallons a minute or something like that, or even more, like when you got 1 1/4 tip on that solid bore 2.5, that's tremendous. But let's go back to the 2-inch. What we have found is that with the newer materials used in the manufacture of our fire hose, and this is for all manufacturers, because they all have access to these different materials. The 2-inch hose, the liner system, the outer jackets, and so forth, can move greater amounts of water with lesser friction loss. And so when we look at that, we look at the weight of the water in a hose line, of a 2-inch hose line. And the other thing is the couplings. You know, there's some people who wanted to run the 2.5-inch couplings, and I stated it in the video. I said, you don't really need 2.5-inch couplings, but it's something that, you know, some people want for their own department's reasons. But like we've said, when we go out and meet with and work with departments, 1.5 inch coupling actually has 1 3/8 waterway. So if you take a look at an 1 3/8 waterway and compare it to the 1 3/8 tip on a deck gun at 80 psi, it's 500 gallons a minute. But we're not looking to flow 500 gallons a minute through 2-inch line, but we are looking to get substantial flows that have great knockdown power, and to provide a intermediate size hose line that has knockdown power and mobility. And it's a great thing, especially for fire departments that don't have a lot of people to put on a line, put that line in service quickly and easily. And then the other benefit of the 2-inch line, it's a great standpipe line. And again, that's something when we talk about, like, I think we talked about it in our last program. Take a look at the manufacturer's hose and what they have out there available, and find out what of their hose lines that they carry is going to give the best flow and manageability within the line. So what we've seen is that, and of course, you take a look at the latest standards for the NFPA when it comes to standpipe outlets. You could take 2-inch hose and make a great standpipe line out. You can get 240, 250, 260 gallons a minute. And I was working with a fire department several years ago, and we were able to attain flows of 270 gallons a minute with 2-inch hose and 1.5-inch couplings coming off a standpipe outlet at the 10th floor. Yeah. So, that's quite a thing. So anyways, I know that's kind of a big lead in, for
yeah, but let me back you up one spot.
Yeah.
The crew that was helping you with the video, did they have experience with 2-inch line before the video?
No, I don't think they did, because
and what do you think their response was? What did they tell you when they started playing with that?
Well, when you saw the flow meter, and that flow meter, by the way, was set to flow, or I shouldn't say this flow meter. The flow meter showing was showing what we were flowing, and we had backed it down to 240 gallons a minute. So you're looking at 240 gallons a minute, a 2-inch line, and like I said earlier, the weight of the hose line with the water in it,
the guys could appreciate that.
Oh gosh, yes.
Yeah.
Oh yeah. I think everybody who we've demonstrated the 2-inch line to, when we go out and we've done our work with other fire departments, they're all impressed by it. Many fire departments feel that they need to look at it more closely, and many fire departments have gone to the 2-inch attack line. Mm-hmm. So it's got such capabilities. Like we said, you got 3 people coming in on an engine. Well, now we can get great knockdown power, especially for your bread and butter fires. 1, 2, 3-story houses or doubles or whatever, apartments and things like that. So,
yeah. Well, let's have Chad roll it up, and let's watch the video, and we'll come back and talk about some more.
Okay, sure.
Bear with me.
Jack, you get that?
Bear with me for just a second, guys. I got it. Thought I had it pulled up. It went away. Let me get it pulled up. All right. Boom, boom.
At least everybody takes a tour of our website right there. That's kind of nice.
Yeah.
Yeah. That's a shameless plug. All right, where is it? There we go. We're going to do the 2-inch hose line.
Okay. Yeah.
All right. Hang on just a second. And all right, here we go.
Hi, I'm Jeff Shupe, and we're getting down to the brass tacks and hard facts of a 2-inch fire hose attack system. Back in the 1970s, the fire service had 3 basic hose size options: booster line, 1.5-inch, and 2.5-inch attack lines. Also back in that time, we knew that the fire environment was changing. We saw synthetics coming on the horizon, and of course they were making for hotter fires, smokier, more dense, more toxic, and so forth. Many fire departments left the 1.5-inch hose in favor of 1 3/4 hose. 2-inch was on the horizon also. And we saw the 2-inch gaining popularity in the early 80s. And the 2-inch hose was never meant to replace 2.5-inch hose, but it was actually turned out to be an intermediate size hose line. And you can see right here, this 2-inch hose is outfitted with 1.5-inch couplings. Here's 2-inch hose right here with 2.5-inch couplings, okay? This is something that happens when you have a new product on the market. Sometimes there's innovations where other fire departments like to see something like this. Some fire departments say, this is fine. I want to make a point about the 1.5-inch couplings right here. We're going to take a look at it. If you take a look at that 1.5-inch coupling right there, you can also see inside the hose, and you can see it's like a polymer type lining. This lining in here allows for greater volume at reduced friction. So it allows us to give our firefighters a stream that is higher in volume and less of a reaction force, less weight, and so forth. And to match it up with the nozzle, okay? This is a 1 1/16 inch nozzle right here, okay? Old hydraulics formulas, old hydraulics rules would say that a solid tip should never exceed 50% of the hose's diameter. Well, this is 1 1/16 on a 2-inch line. And we're seeing now, again, with the materials used in the construction of the hose, with those greater flows, now we have an 1 3/8 waterway coupled with a 1 1/16 inch tip, and we're able to get substantial flows. And we've seen flows consistently in the 240 to 260 gallon per minute range. And that's a bigger bang for the buck, especially for many fire departments where they're concerned about what their gallon per minute output is for the number of firefighters that they may have responding on an engine. One of the things about the 2-inch hose, when it came into the fire service, and I know I got my experience with the 2-inch hose started back in the early 80s, there was a lot of promises made that the 2-inch hose was going to be replacing 2.5-inch hose. And I think one of the problems that the fire service had was that we didn't have the technology of flow meters available readily to test that theory out. If the 2-inch hose really could flow more than a 2.5 at lesser weight and lesser size and so forth. But a lot of fire departments did go with 2-inch hose, and unfortunately they did away with their 2.5-inch hose back then in favor of 2-inch hose with automatic nozzles. And I think the consensus over time has been the 2-inch hose with an automatic nozzle is not a good fit. I think what happened in a lot of cases, people did not understand that if you're going to go to 2-inch hose and you have a variable flow nozzle as the automatic nozzle is, and it has a variable range per the manufacturer, but some nozzles had a 50 to 350 gallon minute flow range. To push 250 or 260 gallons a minute or more through a 2-inch hose with a 100 PSI nozzle may require a lot more pressure at the pump to get that volume of water through the hose. What happened in a lot of cases is that the back pressure was sometimes very high. And instead of pumping at the right pressure and getting that volume of water that we thought we were getting, the pressure was dialed back at the pump. And of course, the way an automatic nozzle works is that the stream looked good, but the volume of water was not what we thought it was. So as time goes on, many fire departments looked at things, had flow meters because they became available. And as we started realizing the flows, 1 3/4 to 2-inch, what's the difference and so forth. In many cases, the 2-inch line was flowing what an 1 3/4 line could flow. So the question was, well, then why do we have this hose line when we can get the same flow from the 1 3/4 line? So we had to do our nozzle research. And that's where nozzles like this, your low pressure, high volume nozzles. As we mentioned before, this is a solid bore nozzle right here. There's different tip sizes. Different tip sizes at the predetermined operating pressure for a solid tip is 50 PSI. So this is a 1 1/16. You can look at 1-inch tips or 1 1/8 inch tips to go on here also. This hose here, coupled with a low pressure, high volume nozzle, fantastic for firefighters or fire department that want to get in there, move around and so forth. I was talking earlier about the materials used in the construction of the outer jacket. Back then in the early 80s, when we had this hose, you had rubber liners and you had double jackets that were made of materials that required a bigger radius to bend. Unfortunately, sometimes this hose got pulled into a residential structure that had tight areas and so forth. And with only 2 firefighters working it, or in some cases, only 1 firefighter would work it. And the thinking was, because it had 1.5 inch couplings and it was only 1/4 inch bigger diameter than 1 3/4, that 1 firefighter, he could hold this line, right? And it really didn't work out as planned. Over time, with the new materials and so forth that go into the manufacture of these hoses, we've realized it's a great intermediate size line. It has higher volume, and now it has that bend radius that we can go even tighter on that. So it does have the capabilities and so forth. So, but never should this line have been talked about as replacing 2.5.
All right, so good review there.
Hey,
Much li-
first of all, well, I was a lot younger then.
Yeah,
You
but
had some
what,
black in your mustache.
what happened?
Oh,
Glad
okay,
you
now
said
go
that
on.
first.
We were all thinking it. I'm just glad you said it.
Sorry, Jeff, I had to get that in there.
That's fine, man. Yeah,
Okay,
what a couple years does, right?
more than, I think it was 2016, right, Jer?
Was it that long ago?
Yeah,
Jerry?
I think it was 3 or 4
Yeah.
years ago. Yeah, 5 years ago now. That's right.
2016, I think.
2016, man.
Yeah.
Okay.
Time flies, man.
Well, I think that the big takeaways for me in watching that video, obviously hose construction is a huge part of the equation, and then matching the nozzle to it is the other big part of it. The 1 in 1/16 tip hasn't been around for all that long, and for a while there it was called the Shupe tip. Now, is that because your relationship with Jerry at Elkhart and doing some of the research with them and
Yeah.
and getting out and doing some training, doing their
Yep.
know your flow series and
Yeah, that back about 2012, I had that job down in South Carolina, and I had Jerry come down, and we were going to go over this stuff, and we were talking about it, the 1 in 1/16, and I thought, man, this is great because again, when you're talking about getting a better flow, having less friction loss in the line, and having a hose line that's manageable. And again, our thing is, like in our group, what we believe in is taking as much water into battle with you as you can. And when you put a 1-inch hose, Dave Fornell, let's throw one of the old grandmasters names out there, talked about the 2-inch hose in his book, but with a 1-inch tip. So when you take a look at the 1-inch tip at 50 PSI, you're talking lesser volume. Now, over time, with the difference, as you picked up, Jeff, with the materials that are now used, it allows us to get greater flows, lesser friction loss. And I mean, greater flows, like you've seen it yourself,
Sure.
260, 270 gallons a minute, with the 1 in 1/16 inch tip.
which I think leads into the fact that the hose construction is so much better that even if your engine operator is over pumping the line, the hose lines are still manageable with proper nozzle mechanics, and that those higher flow rates are generally above the ideal, but they're usable. We're supposed to shoot for perfect, and we get somewhere kind of close, on game day.
Approximates, right? Approximate values.
So,
Right, sure.
but there, if that guy just is wheeling it up 5 or 10 PSI too much just because of, for whatever reason, that the newer hose is just, it is a compliment to the
Oh, gosh, yeah.
to the whole scene for sure.
Let's throw it out here right now. And just keep it in mind, and this is for everybody when they think about hoses and hose sizes and friction losses. As you increase the diameters of your hose, we're going to carry more water in that hose as we increase the diameter, obviously, okay? But we're going to reduce the friction loss. So like when you take a look at the difference between 4-inch and 5-inch supply line, the old numbers used to say that 1,000 gallons a minute through 4-inch hose was about 19 pounds per 100 feet. Go to 5-inch hose, and you're only increasing, when you take a look at the radius of that diameter, and everybody thinks, oh, it's just an inch bigger, but the friction loss to carry that same 1,000 gallons a minute through 5-inch hose is now down to about 5 or 6 pounds of friction loss per 100 feet. So again, go back to your 1.5 to 1 3/4. Got better flows, lesser friction loss. Now we go up to 2-inch hose, bigger flow, lesser friction loss, and the same thing we go up to 2.5 and so on. So, all right.
Well, I appreciate the quick rundown on that. John or Chad, do you want to chime in on either that 1 in 1/16 with the 2-inch line? Chad?
Yeah, I was just, the 240, that's really on the low end. that I've found since I've been with y'all.
I
I
agree.
mean, even if you put it through Elkhart's little their app that gives you all the friction loss, those numbers really don't apply anymore with the hose. I mean, if you put it through the actual formula, it comes out 237 gallons a minute. And I think my department, we hit 260 with it. Actually, we hit more than that, and I dialed it back to get us at 260 and said, that's a good place to be. We'll stop there.
Right.
And that's what I set our pressure and flow meters at on our engines. But it's a game changer for us.
Yeah.
For a lot of places.
All right, John, anything or?
Jeff talked about how we've had it in Cleveland. We've had it forever, since, boy, it was around the time you got on the job, Jeff, in Cleveland.
Before.
And yeah, and guys didn't really use it. It sat up there, got all moldy. It was definitely an afterthought. Over the last few years, I've seen a lot more guys thinking about using it off the bat. It's definitely something to think about, especially on slightly larger fires. Something that's not a 2.5, but definitely an 1 3/4 is not the way to go either. A lot of guys are using it, so it's good to see. When you tell guys the numbers on the weight difference and the friction loss and the nozzle reaction, I think that's all great and stuff. But when we show them the numbers on the flow, I think that's a game changer right there.
Yeah, it really is.
It's interesting because, again, we just mentioned it a minute ago, we're all about taking as much water into battle with you as you can. Just for that whatever incident, you want all the water and more if everything goes from black to orange. And I've come across something recently where people have been actually reducing the pressure in the line to reduce the flow so they can have better manageability, I guess, that they're looking for.
Pumping the comfort, Jeff. You kind of touched on that in the video,
Yeah.
Guys are dialing it back at the pump panel so guys can handle it out in the field. Well, it's all great and everything, but when you're flowing 75 gallons a minute and you wonder why the fire's not going out,
Yeah.
that's the advantage of the 2-inch. And, when you have the flow meters and stuff and you can see what you're actually flowing, I think it's a big difference.
Jerry, would you like to weigh in a little bit on that?
Sure, just real quick. I think John just hit on it. We can talk about this forever, but like when we do our strategic fire training, we show the guys, we get the lines in their hand and they can feel it and they're seeing the measurements and it gets real then. Again, you can talk about friction loss and nozzle reaction and all that stuff, and everybody's an expert at the conference table, but get out there in the street and do it. And that's when people become believers.
Right. All right, great. So we want to touch on one of your videos as well, Jerry. We want to get into speaking of flows and reducing flows and things that can happen. You did a very interesting video on the hose kink. And when I've watched that video, I think it's a great production. I think it really does show a lot. The only thing I wish there had been more of a, I guess, a control group where there was a different type of hose. And I know that like production and time to put it together and everything, because everybody can argue, well, that wasn't the right hose. You shouldn't have been using that hose. But in general, I think that video does show that if you're running any kind of, whether you're running a high pressure nozzle system or a low pressure nozzle system, that kinks are part of the business, and they happen. And if you don't have the best equipment, then you really need to, everyone needs to be tuned up to get after those kinks and straighten them out. Can you give us a little background from years ago when you were setting that up with Elkhart?
Sure. A couple of years before that, we had done some testing about airflow around nozzles, and we just, we all have these preconceived notions that like Jeff was just saying, we've got to have a 2.5. Well, if you have a 2-inch line, it does the same thing a 2.5 does. and it's better, why don't we use it? So we kind of did the same thing. It was just a fun thing we started with kinks, because the rumor was, or the urban myth was, 20 psi for the first kink loss, 30 for the second, 40 for the third. And we just said, it was myself and Chris Flatley and Timmy Pillsworth, and we just said, it doesn't sound right. It just, let's test it and measure it. So that's what we did, and we came up with some very interesting things, as you'll see in the video. But I think the bottom line of the whole thing is, we can talk about flows, we can talk about this nozzle and that nozzle and this hose. You got to measure it. You got to measure it. You got to measure it. It's as simple as that. I mean, I think Jeff Shupe did a great job talking about the volumes and flows and measuring it. You got to measure it. And if what I want people to get out of this video is, what we think may be happening with our hose and our nozzles maybe isn't. And if we measure it, we get the facts, instead of, I think, you think, somebody else thinks something different,
Great. Well, that's a good lead in, Chad. Can you bring us up on screen here with that one? Right after he
Muted.
turns on his mic. Yeah.
Just trying to find it.
All right.
There we go.
This is Jerry Knapp giving you the brass tacks and hard facts about the effects of kinks on your fire attack system. We conducted an experiment here to see the effect of various different kinks on our fire attack system. We started with one 90-degree kink, increased that to two 90-degree kinks, moved it up to one 130 or approximately 135-degree kink, turned that into kind of an expanded Z. So there's two kinks, compressed that Z. So we had essentially two 180 kinks like you may have in the bed of your hose bed, and try that each with different nozzles. The nozzles we used were two smooth bores, 1 7/8, 1 15/16 at 50 PSI. The combination nozzle we used was 150 GPMs at 50 PSI. And the third was a 100 PSI automatic nozzle flowing 150 GPMs. I think you'll be very surprised to see the results. There's two important facts here. One is you have to test to be sure your assumptions are correct about how many GPMs you're losing. The second is you need to test your fire attack system. You can't take our data with our hose, our nozzles, and assume your hose, your nozzles will act the same way.
Here we are establishing our baseline for the 7/8 inch smoothbore nozzle. We are flowing 160 GPMs. It's important to note that the margin of error is about 10%, and at a flow of 160 GPMs, the upper margin of our error would be plus or minus 16 GPMs. Now we put one 90-degree bend in a line. Not much loss of a GPM, probably due to the fact we're using premium quality hose. The hard fact here is premium quality hose resists kinking and has an effect on your fire attack system. Here's two 90-degree kinks. Now we're at a flow of 153 GPMs. You'll notice we had a hard time maintaining our first 90-degree kink. The single 130-degree kink resulted in a flow of 145 GPMs. Two 130s, or what we call the open Z, dropped the flow down to 134 GPMs, a loss of 26 gallons per minute. Finally, making it a closed Z, or two 180-degree kinks, resulted in a flow of 117 GPMs. It's important to note the old wisdom of each kink dropping your flow by 10, 20, or 30 GPMs just is not a fact. The brass tacks and hard facts are there is no common or standard loss in GPMs caused by kinks. Moving on to our 15/16 inch smoothbore nozzle, our baseline flow is 185 GPMs. A single 90-degree kink drops it down to about 178 GPMs. Two 90-degree kinks make little difference in flow. Here, our 130-degree kink sets us at about 162 GPMs. Two 130-degree kinks puts us at about 140 GPMs. Finally, the closed Z brings us down to 126 GPMs. Our fixed GPM combination nozzle is rated for 150 GPMs at 50 PSI, and that is our baseline. One 90-degree kink resulted in no appreciable difference. We are still within our margin of error. Two 90-degree kinks has similarly no effect. Now we start to see a drop in GPMs with one 130-degree kink. Two 130s drops the flow down to 82 GPMs. Interestingly, with our closed Z, we actually see an increase in flow. We believe this is due to the nature of the way the hose kinks when it is forced into a 180-degree kink. If you look closely at the hose, you'll see there are actually two creases in the line that form the kink rather than one sharp crease forming the kink. This increases the diameter or orifice inside the kink over what you would get with one 130-degree kink. The brass tacks and hard fact here is this: our assumptions about kinks may not be true. It's important to measure and evaluate your fire tack system. And last, we have our 100 PSI automatic nozzle with a baseline flow of 150 GPMs. We were curious to see how the higher pressure of the line would impact our flow, since the hose would be more kink resistant than a lower pressure line. Here you can see that one 90-degree kink has almost no impact. Again, two 90s affect the flow very little. We're at a flow of 144 GPMs. Here are the results of the 130-degree kink flowing 139 GPMs. Our open Z has dropped the flow significantly to 108 GPMs, a loss of about a third of our flow. And the closed Z brings our flow down to 70 GPMs. The quality and reach of the stream still remains good. However, we're flowing half the GPMs of our target flow, which is one of the characteristics of an automatic nozzle. Here's a recap of the brass tacks and hard facts of how kinks affect your fire tack system and your target flow. First, there are no common loss figures for typical kinks in your fire tack lines. The old adage of 10, 20, and or 30 GPM losses due to kinks is simply not true. Second, smoothbore nozzles generally suffer less reduction in flow from kinks than do fixed or automatic nozzles. Third, you need to measure the flow of your fire tack system to see the effect of kinks on your particular hose and nozzles. The hard fact here is this: we got specific results with the testing we did. You need to do your own testing. You saw how we set it up: a couple pieces of webbing, some different kinks, a couple carabiners, something you can do in your firehouse parking lot, but you have to test your system to see how your fire tack system is going to react to those specific kinks.
That's a great video. I'm just all around great production, good information. And really just smashing some of the myths that I was taught too. I mean, that's what we were always taught about kinks. It was a certain percentage per kink. And so much of it's predicated obviously on the pressure in the line and the nozzle you're using. So if we're concerned about staying within our target flow of at least 150 gallons a minute, I mean, it's clear by those numbers, like which nozzle does that consistently throughout the most amount of kinks, that's the 15, 16. So again, for us, it's just more verification of what we're doing and where we're headed with fire tack is high quality hose with a 15, 16s.
I think it's important that we think about our fire tack system. And I describe that as from the discharge or from the intake side of the pump to the discharge side of the nozzle. And I think Jeff used the word equation before, and it really is an equation. What kind of hose, what kind of nozzle, what's your target flow? Does your pump operator, have it dialed in right? Chad was saying how he's got his set now. So it's really important that to think about your fire attack system. And I think that's as strategic fire, I think that's kind of what we do. So, so I think it's a good way to think about it.
Yeah, absolutely.
Hey, real quick, Jerry, that was 4 years ago. You don't look a whole lot different from the two.
Well, I'm a little shinier, you know.
But you had a
Right.
helmet on, so we couldn't see that.
That's true. See, I should have had my hat on and nobody would know, you know.
I think another thing brought up though in our both of our videos so far, and that is you've got to test your own system, your own equipment. You know, a great point, Jerry, about using the higher quality hose, and it's supposed to be more kink resistant and so forth. And you know, that's really what it comes down to. The other thing is chasing the kinks out of a hose line. That's something that's supposed to be taught in basic training. So you're supposed to carry that with you throughout your career. So
Truck
right.
man or engine man, doesn't matter.
Doesn't matter
See a
what color
kink, you're
that
supposed
front
to
piece
relieve
of
it.
that helmet is.
That's right.
You know, what I think is interesting is that was what, 2016. So almost 5 years ago. Look how far the hose has come in 5 years. Because, you know, the hose we use, it's hard to make it kink if you have it at the right pressure. And I mean, I wonder, you know, it'd be almost fun, Jerry, to do this test again on some of our newer hose.
We should do that, you know.
Revisit
Yeah, it's
it.
5 years later, you know.
Absolutely. Yeah.
So it's
Great idea.
I think the thing we get out of this is that there's so many variables that, you know, you think, and I used to teach it. I used to say 180, 50, 20, 180 GPMs, you know, 15, 16 tip, 50 PSI nose pressure, 20 PSI friction loss. And it's just not that simple. There's variables, you know, and like Jeff said, the equation, you know, we all want to make this stuff super simple, but there's a lot of variables that, you know, and Chad worked through those, and he's got his 2-inch line dialed in, but you got to control those variables, you know.
So I hate to talk about the elephant in the room here, but why? I mean, this is like one of the most divisive things I've seen in the fire service, whether you're a 7/8 guy or a 15/16 guy. And I mean, it'll lead to fights.
Yeah. But again, you can't look at it in a vacuum. You know, if you're going to if all you're going to is small building fires, and you're not gonna go to a high rise on the 15th, the high rise fire on the 15th floor, maybe that 7/8 is good for you, you know. Or maybe you got wimpy nozzlemen that can't hold a 15. You know. So again, it's a big picture kind of thing. I think, Chad.
I guess it's that circumstantial thing.
Yeah.
But the
absolutely.
difference is, I mean,
So-
truthfully,
Go on.
I'll go ahead. When we first got smoothbores, we had to use 7/8. That's what we bought. And it took 3 to 4 years to get to the 15/16. And truthfully, I replaced them and nobody knew I replaced them. They couldn't tell the difference.
Yeah.
Oh, that makes sense. Yeah.
Yeah.
If their nozzle mechanics are good,
Right.
the only difference is more water coming out.
Right.
And they don't, you know.
And that's the whole thing about it. You just don't put a nozzle like that in somebody's hand and say, okay, good, now you're going to do better with it, or you're going to flow more with it. No, you have to have in place, number one, company level officers who are worth their salt. Okay. In other words, they're going to take their people and train them in nozzle mechanics and their pump operator to pump at the approximate right pressure. And when it comes to making the attack, using proper mechanics of the nozzle and things like that, and then shutting the nozzle down or bailing it down, whatever is chosen to do at that time, then you're moving it together as a team. It's all about hose management at that point. And this is why I couldn't believe it when I started hearing people that were actually dialing back the pressure to a lower volume. In other words, why did you go to 1 3/4 hose anyhow? Why don't you just go back to 1.5 inches? If that's that big of a problem. But see, that's a training issue with so many fire departments. So, and I bet you a lot of these guys who are talking about all this stuff about firefighting environment is so much more violent than it ever was back then. Well, back when, you know, and we need this water. to do that, to knock these fires out, well, then why would you tell your people it's okay to use less water? Take as much water in with you as you can.
Right, right.
I mean, Jerry,
John, are you chomping at the bit over there? You look
Couple
like you
times, but
hungry.
you guys just keep going. I keep losing my train of thought here.
Try to
I
keep
was
up,
gonna-
buddy.
I was gonna go with Jerry about knowing your system. Shupe, you and I on engine 11, we tested theirs, and we lost 15 psi from the panel to the discharge, which fine, whatever. But when you add it into all the other things, all of a sudden you're down a lot of psi at the tip.
Yeah,
So
that's a huge curve when you run this low pressure system.
Let me
Right.
tell you,
Well,
Let me-
regardless of the system you're running, because you're now at a deficit of essentially one extra section of hose that you're not accounting for one way or the other.
sure.
And you think you're going in with 185 gallons a minute or 160, whatever you're using, and you're not. You're only going in with far less. So we think we're going in with all this water, and are we?
This
It's
is the
something we've
problem,
talked about since we started going out, as a group.
John. This is one of the problems. I'm trying to look for the right word to say here. This is one of the problems you run into when you deal with departments that have an SOP that says pump at, let's just say 120 or 125. And they have a new engine comes in, or like in the case of a bigger city where they get a whole bunch of engines coming in at one time. And then you have guys who say, let's go with the smaller or lesser flowing tip. So I had a call one time from a fire department in Northeast Ohio several years back. And he said, come out and take a look at our engine. And we got solid bore tips, and we got 7/8, and I think it was they were using. It wasn't 15/16. And they said, we don't seem to be getting the flow that we think we're supposed to be getting in this. I said, oh, really? Well, let's start off with the pump, like you guys are talking about. Open up the door to the pump, the inner workings of the pump. A department that uses SOP to say you pump at 120, 125, 130, and you've got an engine with 3 elbows coming off the discharge manifold, and then you're pumping into a 7/8 tip.
We
Enough
had
said.
that up in
One-
Iowa. Remember that, Jeff?
Yeah, that was
Mhm.
another place. Yeah.
Yeah, the two
This is-
hose beds right next to each other. One had 4 elbows, 90 degrees, and the other one had 3.
Yeah.
And all of that just adds up.
Oh, it eats up your
Each
flow.
one individual is nothing, but you add them all
Right.
together, and all of a sudden it is a big deal.
guys, y'all are a lot smarter than me. I've always been taught, and I don't know where I picked it up. It may have just been an urban legend type thing, that every bend in your pump is about 10 psi.
No.
And that's where you have to. I mean, I actually put gauges at every, at the coming out off the pump, one at the 100-foot mark and one behind the nozzle to see where my loss was.
Mhm.
And
Yeah.
It depends on the flow, how much flow
Yeah.
you're trying to push through there, so. What's interesting in here in Rockland, we're big on every year doing the testing the pumpers, they test them at draft, and it's a big deal to get that done. We never test our fire attack systems. So we know the
True.
pump's in great shape, but we don't really know what's coming out the end of the nozzle, which is probably the business end. But so I've tried to kick that dog, and everybody just kind of looks at me and makes a face, and it's like, nah, we don't need to do that. I'm like, okay, it's up to you.
Well,
Have y'all-
go ahead.
have y'all seen where, you said, hey, it's bad SOGs to pump to 120. Have you seen a trend where you're not pumping to a pressure, but you're pumping to a flow? I know our new pump, our new engine has flow meters on every hand line.
Yes.
So
Yeah. And I can agree with that to a point.
if
know
they're
why?
calibrated correctly,
There you go. They have to be calibrated. Exactly.
and they have to be recalibrated.
Yeah. Give an example. John, I remember when we got 12 engines coming into the city. 6 of them had one make of a pump, and 6 others had another make of a pump. What do you think's going to happen there? You have this manufacturer's pump and this manufacturer's pump. And again, that SOP that says pump to this. Well, what's the discharge manifold like on this manufacturer's pump versus this one over here? And how does it affect your flow? So yeah, when it comes to flow meters on the outlets, I've seen departments that have had the split gauges also, where you have a pressure on one half and a flow meter on the other half. So again, the whole key is calibration.
Yeah.
You come to the northern environment in the wintertime, and you look at that engine sitting out in the apparatus bay, and then one engine's reading 80 right now as it sits out there in the bay.
She's just ready to pump.
Yeah.
She's
I don't
ready to
get that.
go.
Jeff, I mean, I mean, we have how many different makes of pumpers in Cleveland?
Yeah.
So that even have an SOP to say pump to 125.
I'll see that's
I mean,
a training issue. Start
I
with the
agree.
nozzle pressure and the size hose line. And Jerry, I know you mentioned that a little bit ago about, how are you going to dumb it down? But in a situation like what we're talking about here, you almost have to have something like that to go for the approximate flow. Hopefully you're going to get that. So.
And that's kind of what you said about approximates. What I teach my guys is, hey, we know that our 1 3/4 with our 15/16, we need to flow that at around 110 to get our flow meter. So we have the flow meter right under the pressure gauge. I go, guys, once you see the 180 to 190 mark, you're probably in a good spot. But then that also comes back to training, like you teach. Is that nozzleman giving it a good flow for that pump operator to actually set? Because it sucks trying to set a pump while the guys are shutting off and shutting on. And that comes back to training. But I kind of do an approximate. Hey, if your pressure is right around the 110 mark, 115 mark, and you got 180, you're good to go. 185, you're in a good spot. There's never a perfect answer for it.
Right. Yeah.
But Chad, I think that's really good because you're training the guys to overcome the variables. You almost don't care what the variables are as long as you're getting what your target flow. I think that's terrific.
It is a big part of the training. Nozzle mechanics, a long bleed and flow so that the pump operator can set the pressure. And that accounts for so much more going into the firefight, as we all know. And then it also reduces the kinks because, when the operator's like, hey, I got to run it at 110, and there's 200 feet of line out, and the nozzle man's looking at the stream like this ain't it. Collectively, everybody, the light bulb goes off. There's a kink. Go find it, and it just makes it happen.
And the only way they're going to know that, Jeff, is by training. Go back to what Chad said.
Yeah,
you're going to know. You're going to hold that hose line. You're going to be like, I don't care what the pump says. This isn't right. This is hot, or this is under pumped. You're going to know right away.
Yeah. That 3-second blast into the neighbor's bushes. That just doesn't show you anything. Not doing yourself any good. Got to flow enough water to let that operator set that pressure.
I always try to just go ahead and blast it into the house if I'm going in anyway. If that hit above where I'm going.
That's it. Yeah. I guess we could go a little deep on this if you want, guys, but I'd like to maybe move towards talking about our class at FDIC and where we're going to show, use, and teach a lot of the stuff that is on the brass tacks, hard facts curriculum there. Jeff, you want to take us through what we're hoping to see and do there?
Yeah. I'm glad we're into this part. By the way, Jerry, you're muted. Jerry?
I think he wants to be.
Yeah.
Oh, okay.
It helps me sit here and be zipped, so. And I can burp and make other bodily noises without bothering you guys.
Okay. Yeah, think out loud. Okay. Yeah. Our class at FDIC on aggressive engine company firefighting. Again, if you've been following our Firefighting Fridays, that you've heard us many times talk about, we believe in taking as much water in the battle with you as you can. And we're all about the basics, the principles, the practices that have been around for decades upon decades. Okay. So those who are coming to our class, we're going to run an 8-hour class. We're doing it Monday and we're doing it Tuesday. And it's going to start off. We'll get everybody together real quick. We're going to get everybody. Jerry and I were talking about this afternoon about how we're going to have to really get 50 people together. That's what our anticipated number is anyhow. 50 students off the buses in their turnout gear, and then get them grouped together for an introduction of the class, give the students the goals and the objectives on how we're going to attain those goals together as a team, because we're going to start off with teamwork right away. Look, all this stuff about engine work, and we talk about firefighting, and we're going to get into other stuff about firefighting as we continue on with this show. When you're out there with us, it's all going to be about teamwork, okay? So if you see somebody who's working with a couple by themselves, go help them. And if you see somebody who needs some help on a hose line, go give them help, back them up, whatever it takes to help your fellow firefighter. Yeah, we want to instill that right off the bat. So that's going to be part of our introduction. And we'll give everybody the expectations of their day when they're with us. And one of the things that we will do our damnedest to have that nozzle in your hands as much as possible, going through the different evolutions or workstations, as we call them. And then when we get into the scenarios, and that is our goal. So when the end of the day comes, you can pick up a line of any size and be effective with it and be able to go launch an attack on a fire and kill it. Okay. And that's what we're going to be about. So we'll start off with show and flow. We've been calling it that for years, for God's sake, you know, where we're going to go over different size hose lines. Again, the things that you saw tonight on our brass tacks and hard facts, you're going to work with 1 3/4, 2 inch, 2.5. And we're going to have 4 different hose lines operating, you know, break the guys down into groups. So everybody is going to have the chance to operate those things, not only once, not only twice, but 3 or 4 times before they even break into group work and go to other skill stations. So that's what that's going to do. And by the way, we're going to have the flow meters out there, and we're going to go over the flows of these hose lines that we've been discussing, like tonight. And we'll talk about the pressures and all those things. And again, we're all about that low pressure, high volume system. Okay. Once we get done with that, we're going to have the students break into 5 different groups, and we're going to have, the goal is to have 5 different workstations. And each group will rotate through all the different skill stations. So by the end of that time, okay, we're going to go into scenario work. And we're going to be operating with all of the students as 3-member engine companies. And what we'll do is have them all line up. You, and you're engine 1. Get on that engine. We're going to have you respond in. We're going to give you a job assignment in a scenario, and this is going to be it. When they are done, we'll have the second engine crew come in, and we're going to give them a job. It may be something like backing up the first engine on their attack, or whatever the case may be. When they're done, the third engine, and the fourth engine, and the fifth engine, and so forth. So at the end of the day, you're going to see probably in the neighborhood of 7 to 8, maybe 9 engine crews working in a scenario. And that's going to be pretty interesting, because it's all about coordination. With all this stuff in the modern fire service, hey guys, firefighting is all about control and discipline and following the basics and the principles and so forth. So you'll be able to see what happens when you have a controlled sequence of operations, and we'll be making sure everyone goes through that. You're going to be doing several different things in these skill stations throughout the day. And again, you're going to be employing all of those things when we go into the scenarios. So when that group's done with the first scenario, we're going to break everything down, reload the engines and so forth. Next group we'll give those guys assignments, and everybody's going to be going through this. So it's, yeah, so you can expect to, like I said, you're going to have that nozzle in your hands quite a bit when you're with us. You're going to be doing a lot of hose line work. You're going to have a couple of skill challenges and things like that. And it's going to be pretty good time. Okay.
It's always a great day. I love the class from a teacher's perspective. I just love to show how your methodology of building skills and how each one is related and builds on the last one to the end of the day, where you've got people who have not had a whole lot of time or experience with any one of those things, and they're getting off an engine and they're putting it in service and they're using it. And you can see the confidence level just going up with the participants in the class. And I think that's the biggest win for us as a group. I think when we see people come through our classes, they leave feeling like, yeah, I kind of know what I'm doing with that thing now, and that's great feeling.
Or we've heard talk about this, but we actually were able to do it. Okay.
Yeah, because there's not a whole lot of places where you could throw 1,700 gallons a minute at a building.
That does impress. It is impressive. I got to tell you, when you see all those different appliances and those hose lines operating, and then we get guys to switch off, like when we're reducing the attack. Okay, let's just say one of our things that the students will do, they'll go over door control, 2.5-inch hand line attack, and work with that, and then we'll say, go grab 100 feet of 1 3/4 inch. Now we're going to continue on with this because the fire has been knocked down to the manageability of this size hose line. As it's going to be cool, they'll see that, and when they are told that, what, we didn't touch the pump pressure at all, didn't change it one bit, and they're like, wow, how did that happen? Because a lot of people, again, they've been fed a lot of blue gas about, well, now you got to recalculate. You got to think about this. You got to think about the friction loss in 2.5. And then as it goes through the nozzle and into the 1 3/4 and all this other blah, 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 whatever, you don't have to. You're going to get at least 190, maybe over 200 gallons a minute. Again, quality of the hose, size of the nozzle, and low pressure, high volume system. You'll be able to see that also.
Yeah. Now, as far as FDIC goes, I mean, I certainly hope there's some excitement for it. Having been canceled last year, and I know it's in an off season here, but either you or Jerry, if you guys can kind of comment on your experience with FDIC over the years, from your first time getting out there with the old group, and to what you've seen FDIC come to be over the years. Can you comment a little bit on it, like from your perspective?
Sure.
Is it a whole lot better? Is it much the same? What are some of the parallels?
Yeah, I think it's yes to both of those, Jeff. It's a lot the same, and the same for me is you can, everybody there is a student of the game, and nobody looks down on you, and the egos are away, and you can say, hey, geez, can you show me that? I really don't know that, and everybody is glad to share what they know with you, and so in that respect, I think it's the same. I think it's better. We've fine-tuned the evolutions, especially this engine company station. Like Jeff said, we'll get nozzles in guys' hands. And Jeff, as you said, guys leave, after a day's training, they're ready to go back to their home department, and they're more confident. They've got a good low pressure, high volume system to kind of work with. So I think it's really good. And like you said, as an instructor, you feel you've done the fire service some good. These guys and gals have taken back, these skills that have been learned over the years. And yeah, I don't know, it's just FDIC is just such a valuable experience. Like I said, you just get to rub elbows with the leaders in the fire service, and in a all positive way. And, think about it. What do we all have in common? You get up for breakfast, what do you talk about? Fires. You go to training, what do? You learn to put out fires. You're sitting eating lunch, what do we have in common? We talk about fires. You train in the afternoon, we get that done. And at night, you go to dinner, and then you go to the bar, and what do you talk about? Fires. So, you know, it's really an immersion of, for me, I just think it's great. Plus you get recharged, you know, we all got our problems, you know, but you leave FDIC and you go back home and go, I'm ready now, you know, and you charge the windmill again, you know, so.
That was
Sorry, I get carried away.
no, Jared, God love you. Let it fly, brother. Why, I remember we received a compliment, you know, because remember when there was only one engine group, you know, and that was it. That was like, wow, nobody else is, because that's when RIT and search and rescue and VES and all this other stuff was really popular. And as for one engine class for the whole thing, then all of a sudden it was kind of funny because, oh, gee, that engine stuff, it's a lot cooler, you know, than what we thought, you know. Now everybody becomes an engine expert and puts their own spin on it, you know. And next thing you know, they know how to write a paragraph on what they're going to put out there. And it's like, well, you know what, it's a little bit more in depth than that. But, you know, as Jerry said, I remember we got a compliment from a high ranking, highly respected member of the fire service, captain in FDNY, said, you know what, the interesting thing about you guys is that you're still talking to your students at 11 o'clock at night in the bars, just like you said, Jer. And I thought that was great. And I really, I've always appreciated, yeah, his
Or a hotel lobby.
comment. Well, maybe if we're there.
Everywhere.
I think the one of the greatest things for us 90s kids like me, you know, is having a direct link through you guys into, you know, the 1980s, 70s firefighters that were, you know, the guys that taught you essentially are teaching us by still having you guys in the game. And it makes a world of difference to have that.
So you're saying we're old? Is that what you're saying here?
Yeah.
Like,
And I appreciate you still got gas in the tank, buddy. You know,
There
I really
you
do.
go. It's
I
getting
really
down
do.
there.
It's a great thing though. And it's one of the great things about the large conference, you know, is you get that the long-term interest, you know.
right.
You know, I think the other thing too is we see around here, I see our guys, we're so inbred. I mean, it's pathetic. And, you know, you get out to the conference, you go, oh, well, geez, that's how Shupe and those clowns do it, you know, and it just opens up their mind to like, holy crap, there's a different way to do it. You know, even if you don't disagree with it, hey, it's a different way, you know?
Sure.
So.
You know, hey, Jeff, real quick, going back to what we're going to do with the class, in case there's anybody that had never taken our class, you know, we do show and flow. And that's one of the cool things about this class is the process you use. It's almost like a crawl, walk, then run. Because while you're doing the show and flow, these guys are going to show you how to move the hose the correct way and show you all the mechanics for that. In case there's anybody, you know, listening, you know, nervous, hey, I don't know if, you know, I've heard Shupe can be intimidating sometimes. I don't know why.
Oh, come on.
That was years ago.
Right.
But you know, it's like, and Diederich said, the confidence these students get from taking the 8-hour class, and it's fun again. You know, it's like one of the comments I've heard is I've never had control of a hose line like I do now. Now I feel like I'm controlling it and it's not controlling me. And that's a huge gratification.
There's a lot of people out there that were never taught how to handle a hose line.
Right.
Here you go, kid, go fight it. And
exactly.
That's what you did. And you're right. We have that student at 8 o'clock in the morning. They grab the hose line. They don't know what they're doing. They feel uncomfortable. They can't control it.
Right.
And within a couple hours, they're sitting there and they look at you and you see the look in their eye and it's clicked and they're like, oh, I totally got this now. And it's really cool to see.
And then the older guys that do it, they're like, where the hell was this 10 years ago?
Right.
For the young guys, you can't do it. The old guys still do it.
Got to come back to the older guys all the time.
Yeah, we'll beat you up. Yeah.
I have yet to beat Shupe on a training ground. I think I beat him once on top of an engine. I got up there before he did once, and I cheated.
Would you trip him?
No, I made him talk to somebody.
Oh.
I said he had a question, and then I ran.
It's still fun.
I do promise you do get wet in this class. You will be wet once
Oh,
Hurricane Shupe hits, and
Yeah.
Oh,
it will be
yeah.
a lot of fun.
It's all good. Well, I think we've covered quite a bit of ground, guys. We hit the brass tacks, hard facts. We covered both Shupe's 2-inch video and Jerry's the kink video. I want to say the kinky video. I
Yeah,
almost
not
said
the kinky.
That's a separate thing.
we ran down the upcoming FDIC. So just a big thank you for all the interest and the help from our friends at Elkhart Brass. Obviously, the sponsorship with it for the conference. Fire engineering, FDIC. We're super excited about that too.
Hey, Jeff, real quick.
Guys, yeah.
Not only are we doing hands-on, but 2 of the guys are teaching lectures too. Do you want to go over when they're doing that?
Yeah, last I saw, they were both scheduled to present at the same time. Is that still the way it is?
It is, I think it's Wednesday at 3:30.
House divided.
Jeff's doing his,
Money always talks.
You know how these old
Jeff-
guys are, John.
Maybe
what are you
I'll go to Jerry's class.
There you go. If they put you guys in classes right next to each other, they could just open the wall between the two of you.
Yeah. It'll be a good time.
What class are you doing, Jerry?
I'm doing tactical response to explosive gases in Sagamore 4-5 on Wednesday at 3:30. So if you want to learn about how to use your 4-gas meter proper way and prevent yourself from getting blown up, that's the place to be.
From a guy who's been blown up.
Blown
That
up,
should be
sir.
very good. That should be a very good talk.
Just once. So
It only takes twice, right?
yeah,
You can do anything once.
that's right. And I guess I proved that. So yeah, we'll share what we learned over the past few years about proper procedures for natural gas and propane emergencies. And well, I'll share the things that I thought I'll share the things I did not know that almost got me killed, and maybe it'll prevent folks from having a similar bad experience there. So, but I wish I could go to Jeff's engine company class.
You've heard it before.
Boss, what are you doing?
It's going to be comparing principles and practices against modern practices today. Modern ideas and things like that. And it's just, I think I put together a title of contemporary issues in firefighting. Something like that. It's an engine class.
It's an engine class by Jeff Shupe.
Yeah. Whatever.
That's about it. It's about it.
That's all.
All right, guys.
I like how you say it, Diederich.
Yeah. All right. Well, thanks again, everybody, for tuning in.
Yeah.
We'll see you guys again next month. If we don't see you at FDIC.
You guys at FDIC in our class, you're gonna have a good time.
Here it comes.
You're gonna have a great time. All right.
We've been pent up for a while.
Yeah.
Yeah. Let's make it happen.
Yeah.
Everybody be safe. Have a good night.
All right.
Talk
Good
to you.
night.
Take care.